So let V be a vector space. So of course, if we have a vector space, then we can add vectors to get new vectors. So we can add vectors, add vectors to get vectors. That's what vector addition is. And of course, we can scale vectors to get vectors. And so we can construct new vectors from a set of vectors. And these things are called linear combinations. So a linear combination of a collection of vectors. So if you give me a bunch of vectors, so here's one vector, here's another vector, so say you give me k different vectors, then I can scale each vector. So each vector I can multiply by some number. I can do some number times the first vector. That gives me a new vector. I can do some other number times the second vector. That gives me another number. I can do this for all of them. So there are k vectors in my set. I can scale each of these k vectors to get a new vector, but I can also add them all up. And so if you consider doing this, that's what's called a linear combination. So a linear combination of a collection of vectors is a vector of the form. So a linear combination of vectors is a vector of the form what I just wrote down here. So a linear combination of a collection of vectors is something where you write it like this. So the vectors are taken from some specified set of vectors, and here the ni's, so n1, n2, etc., nk, are scalars, or just numbers that are scaling. Sorry, that says scalars. So we're just scaling them, and they're also the coefficients of the combination. Okay, so a linear combination of a collection of vectors is just anything that you build out from a specified set of vectors. So if you have 4 vectors, then a combination of them is just anything I can build using those 4 vectors. You can scale each individual vector and you can add them together. Okay, so you could, like, for example, let most of the n's be 0. So you could just scale one vector, and that's still a combination, even if the set is 4 vectors. I can just scale one of them and set all the others to 0 by scaling them to 0. So that's all a combination is. It's just a way. It's a vector that's formed by formed from other vectors. Okay, so give me a set of vectors. I can build new vectors. The vectors you build are called linear combinations. Okay, and so we consider the set of all possible linear combinations. That is called the span. Okay, so here's just a definition. The span. So the span of, if you give me a set of vectors, so the span of a set of vectors is the set of all possible linear combinations. So built using the specified vectors. Okay, so if you give me k different vectors, then using vector addition and scalar multiplication, you can build new vectors. Any one vector would be a linear combination. The span is all linear combinations, so the span is all vectors that can be built. So I'll say that in words. So the span of v1, vk is the set of every vector that can be built using using scalar multiplication using v1 through vk. Okay, so give me some vectors, you can combine them to get new vectors, and the span is all possible vectors that you can build from that specified set of vectors.